Hello everybody, this is Nick. I'm continuing our series. This is the second recording in a series on solar panels. So let's start where we left off. First of all, in the previous video, we calculated we need 1,866 watt hours. We need to collect watt hours per day. We also went to the web and found out in our location, South San Antonio, the sun shined 4.1 hours average per day. We divide those two quantities. That says we need a solar panel that will collect instantaneously at bright sun 455 watts. We can almost take this number and go to the web and pick a solar panel, but we got one or two more steps before we get there. So let's talk about the batteries. In the previous videos, our batteries needed to store 6,666 watt hours. All right, but we know there's some phenomena in batteries that we need to think about and actually calculate for. One is that if you look at the data sheets, you go about to the last page, you get your magnifying glass out. Batteries are rated at 77 degrees Fahrenheit. Well, it turns out in South Texas, in the wintertime, it gets cold. And when the sun doesn't shine, and it doesn't shine for several days, it gets really cold, maybe like freezing. So the battery manufacturer said we better derate our battery by 20%. So we're going to divide by 0.8. Now something else, a phenomenon in batteries that you're well familiar with, especially if you own a laptop, is that when you first buy it, that thing goes 5-10 hours before you got to recharge it. Give it about 6 months, and anytime you're thinking about using it, you got to plug it in. So batteries degrade over time. They're due to two functions. One is the number of charge-discharge cycles, and number two is just flat age. So we're going to derate it again for age. All right, so we're going to divide this out. It turns out instead of a 6,000 ampere hour battery, we need a 10,400 ampere hour battery. Okay, now, lo and behold, when we go to the web page to buy a battery, we find out they're not rated in watt hours, they're rated in ampere hours. Right? So now we got to go back to our load and we got to figure out what voltage the load runs on. It might be 12 volts, it might be 24, it might be 48, it might be anything. But if we know the nameplate of if we have the devices or we look at the data up on the web, it gives us a voltage, all right? So now we know the voltage that the system runs at. Now we can go calculate the capacity of batteries and what's rated in ampere hours. So if you've been paying attention in class, is that the current is equal to the power divided by the voltage. So we divide by the voltage here. Okay, so the power is just 10,400, and the voltage is 24. We got that off of the spec sheet. So now we know we need a battery that's got an ampacity of 333 amp hours. And you go to the web or your catalog page and you can find batteries rated in ampacity. All right? Now, the deal gets slightly complicated. In fact, that now you got to choose a chemistry. All right? Your three main choices today are lead acids, nickel cadmiums, or lithiums. Now, battery technology is moving, and what you know today, probably by tomorrow will be changed. There'll be a better battery coming out. So this data is dated. But let's just choose lead acids. That's the chemistry we're going to choose. All right. So we go to the data sheet on the batteries, and we see that that the normal battery voltage per cell for lead acid is 2.24, but we got to charge that battery at 2.4 volts per cell. All right, so we got a 24 volt system. That's going to say we're going to need 12 cells. All right, so 12 times 2.4, it says, well, the battery when we're charging in full sun is going to be 28.8 volts. It's total system voltage. Now, also prominently displayed in the data sheet is the cutoff voltage. They're telling you that on lead acids, you want to cut off that battery when it gets down to 1.8 volts per cell. And you got 12 cells. Is that when the system voltage drops to 21.6 volts, you need to turn it off. And it further states if you discharge that battery below 21.6 volts, you ruin your batteries. All right, and that's why initially in the last video we put a switch in there to dump the load, to disconnect the load. That's so we don't discharge the battery. Now you might ask, look, we designed this thing pretty conservatively. You know the sun the sun ought to shine. We ought to almost never run out of sun. Well, poop happens, you know. There's a guy by the name of Murphy. You know, and the law after him, Murphy's Law, says if anything can go wrong, it will. There's the Boudreaux corollary. You see that fellow Murphy? He was a damn optimist. So what might make a failure in your solar system? Well, you got it out here. It's out in the woods somewhere. You know, the birds might poop on it. So what you thought was a 100-watt solar panel might be now a 50-watt. Come the first cold season, this system fails, your boss comes around and looks at somebody, shoots somebody. So a little rule of thumb is, how do you keep birds from pooping on the solar panel? You put little plastic ties up here, little black plastic ties. The bird tries to come land on this thing, his feet tickle that, he feels that plastic tie and he figures out this is not a good place for me to land. So, you know, little old 50-cent tie wraps here, plastic ties, will keep the birds from pooping on your solar panel. These are a little trick that some or some might not know. Okay, now something about solar panels is that solar panels they're rated at a certain voltage, but they put out a voltage range. Okay, and typically when you got little load, you got a lot of voltage, and when you got lots of load, the voltage falls off and actually falls back. All right, falls back. Well, at this voltage, you may be overcharging your batteries. So remember, in our solar panel system, we had some boxes in here. Is that the first thing we want to go through? This box is an important box. That's the battery charge controller. All right, and it does a couple of things. One is it protects your battery. Is that it does not let, a well-designed battery control charging will not overcharge the battery. And you want to put this switch in here so that if the bird poops on your solar panel and you don't get out there and clean it off fast enough, it disconnects the load. Okay, so now we've got to figure out how to rate this guy. Well, again, we know that the charge controllers are typically rated in current, and once you pick the current or the power, is that you now have to pick the charge controller. So how much current does this thing have to do? Well, we knew the load was 75 watts. We divide by the system voltage. That says that we got to supply 3.1 amps for the load. All right, this is the load. We also need to charge the battery, so the battery we decided we're going to put back in some every day, and we're going to put back in 660 watt hours, and the sun is going to shine on that thing 4.1 hours. All right, and we got a 24 volt system. So our charge current is now going to be 6.7 amps. So the charger now has to handle the sum of those two numbers, or 9.8 amps. All right. Now, good engineers build in some margin. If you find a 10 amp charger, you may want to think about a 15 or 20. If it doesn't cost you a lot more extra, don't ever design up to the limit. All right, so now you know you need a 445 watt solar panel. You can go to the web and find one. You now know you need a battery with this ampacity at this voltage. You can go find one. And you need a car charge controller to handle this, and your low voltage disconnect has to be able to switch about this current here. So now you've got all three systems designed, and you go to the web and you go find them. And also, in your battery charge controller, you want one that's a peak power tracker. And what that does is that tries to not let you deliver more current than your solar panel can deliver. This is called the max peak power point. All right. So guys, this is the end of video 2. And if I get real ambitious, we'll go on the web and try to pick out some of these solar panels, reminding with these numbers involved. So long for today.